Hello everyone, welcome back to the another session in Design and Analysis of Algorithms. The topic name is Parallel Programming Models. This topic you will find in 5th unit as topic number 6. Now let's get started. Applying to the computer architecture, algorithm can be written in two ways. The one is sequential, the other one is parallel. So sequential we are not going to touch in this video because already we were given what do you mean by sequential and how the programming is done with sequential processing we were discussed in the last video. Now this video is pure about parallel programming models. That means you can execute your task parallelly. So how many ways you can do it, that we are going to talk in this video. That is what the topic name, parallel programming models. There are four kind of different models, which are shared memory model, message passing model, which is also called as distributed memory model. The third is hybrid model. Fourth is data parallel model. Now let's talk about each. The first one is shared memory model. In this model, multiple processors share a common memory space. That is what global memory space. Global memory space or common memory space. Processors can communicate. Let's suppose that the work is divided among three different processors. Now, processors can communicate by reading from and writing to the shared memory. So, common memory will get shared among all these different processors. Now, programming paradigm for shared memory model is what? OpenMP and POSIX threads, or this is also called as P threads. So shared memory model can run with thread and without thread. Now the advantages with shared memory model is what? Easier to program and understand as the memory is shared among all the processors. Disadvantage is what? Scalability issues due to contention for shared memory, difficulty in managing data consistency and synchronization. And the second model is what? Distributed memory model. So in this model, each processor has its own private memory. There is no shared concept. We'll divide the memory equally, or we'll distribute the memory equally to all the processors. So each processor has its own memory, and that is what the private memory. Processor communicate by passing messages to each other. That's what this method is also called as message passing. The advantage is what? Better scalability, as there is no contention for shared memory. Disadvantage is what? More complex to program due to the need of explicit message passing and synchronization. The third is what? Hybrid model. In this model, now let's talk about hybrid model. Combines shared memory and distributed memory models. Typically, each node in a distributed system is a shared memory system. Advantage is what? Can leverage the benefits of both shared and distributed memory models because it is a combination of both the models. Disadvantage is increased in complexity in programming and managing the resource. The last model is data parallel model. In this model, the same operation is performed on different pieces of distributed data simultaneously. The main advantage is simplifies the parallelization of algorithms by focusing on data distribution. The main disadvantage is not all algorithms can be easily expressed in data parallel manner. So these are what different kind of parallel programming models. Now, let's extend the RAM model to allow for multiple processors, gives rise to parallel model known as the parallel RAM or PRAM. This is the synchronous parallel model in which all processors share a common memory space. Because of its conceptual simplicity, this model seems to be model which at most all parallel computers evaluate in one way or another. The PRAM model is also well suited for discovering the inherent parallelism. Finally, the PRAM model seems ideally suited for finding general paradigm which can be used to develop efficient parallel algorithms. Now we will see different versions of PRAM. There are basically three different versions of the PRAM model. The one is EREW, exclusive write, CREW, exclusive write and concurrent write, CRCW, concurrent read and concurrent write. Now let's talk about this. There are basically three different versions of the PRAM model, each differing from the other in how it resolves the memory conflicts. The most restrictive version is the exclusive read and exclusive write. It is also called as EREW. EREW PRAM, in which no simultaneous reads or simultaneous writes are allowed. And the next is CREW, allowing more than one processor to simultaneously read from the same memory cell but restricting concurrent writes is the concurrent read and exclusive write PRAM. And the third is what? If more than one processor is allowed to simultaneously write to the same memory cell, is the most powerful model, the concurrent read, concurrent write PRAM. The method of resolving write conflict varies, but the two most common methods are based on defining the model based on one of the following rules. Those are: restrict all processors writing to the same location to be writing the same value, and when k is greater than 1, processors are writing simultaneously to the same location, or exactly one of these processors are succeed. So these are what the rules to follow when you are working with the parallel programming computation. Models are different, computation is different. Models, we were talking about the 4 models. Those are what the models which are existed. And when you wanted to do computation, what type of computations basically will do in the memory? Read and write. So when you wanted to compute these kind of operations, you need a PRAM. That is what parallel RAM. So we will be going to have some categories as we were discussed just now. So those are the categories to perform read and write operations in the processor. Now let's talk about simple parallel divide and conquer. The parallel divide and conquer technique is as follows. Given some problem P, divide the problem into small number of subproblems similar to the structure to the original problem but smaller in size, and then solve each subproblem recursively in parallel. For efficiency, the subproblem solution should merge quickly in parallel once the parallel recursive call returns. So here one important point is what? If P is talking about sorting, you cannot do other operation in P1, P2, P3. That's what. And sequential subsets and Brennet's theorem. So the sequential subset technique and Brennet's theorem both involve constructing an efficient parallel algorithm from existing algorithms, which may not be very efficient themselves. In the sequential subset technique, perform a limited amount of sequential pre-processing on small subsets of the problem to be solved, and then apply a parallel algorithm to finish solving the problem. In some instances, some sequential post-processing needs to be done on each subset after the parallel algorithm computers. Now what Brennett theorem will say is, it's a technique to reduce the number of processors needed to solve a particular problem. If an algorithm is designed so that the large number of processors are idle during much of the computation, then Brennett's theorem may be of use. This theorem is summarized as follows. That is, any synchronous parallel algorithm that runs in t time steps and consists of total number of n operations can be simulated by p processor, then the time of the problem is big O of n by p plus t. There are two qualifications to Brennett's theorem before it can be applied in the PRAM model. First, compute ni at the beginning of step 1 in big O of n by p time using p processor, that is, determine how many operations are actually to be performed in step 1. The second is what? Exactly know how to assign each processor to its job, that is, be able to direct each processor to big O of ni by p operations it is to perform in simulating step I. So this is about how the way you have to choose a model, how the way you have to compute operations on that parallel programming model, and the Brennet's theorem will help you out to exactly segregate number of processes to perform number of operations. Now there is one more technique, and this is what recursive doubling. Recursive doubling is a technique that can be thought of as being a complement of the divide and conquer paradigm. Divide and conquer is a top-down technique. Recursive doubling is a bottom-up technique. The main idea is to start with small subsets and iteratively combine them in pairs until the whole program gets solved. Recursive doubling technique can be described by two problems: list ranking problem, parallel prefix problem. The first is what? In the list ranking problem, given a linked list represented as an array of pointers resident in memory, compute the distance from the tail of each element in the list. The main idea is to assign a processor to each element in the list, and at the each time step set each element pointer to the pointer of its successor with each iteration. The distance that each element has looked ahead is doubled. Hence, in at most big O of log n iterations, each element will be pointing at the tail. Now we'll take an example to prove the same. Now consider, let P of V denote the pointer from V. Let tail denote the node which is the tail of the list. Store a label R of V with each node V, which is initially 1 for all nodes except the tail. Whole label is 0. The label will eventually store the rank of V in the list. In each time step 1 performs the following operation for each node V in parallel. If P of V double is equal to tail, then R of V is equal to R of P of V plus R of V. This is what the ranking step. The double step is what? P of V is equal to P of V. Thus, we can find for each node V in an n node list L, the distance from V to the tail in big O of log n, time using big O of n processors in the CREW, concurrent read, PRAM model, parallel programming model. So we'll take some linked list and we'll work with this. So parallel prefix problem can be solved by recursive doubling. Given a list of some elements and we'll apply to calculate the parallel prefix problem. Even for that problem, the complexity is big O of log n. So we were given the example, so that also you can see the example. So this is about parallel different type of programming model.